Hi everyone, we'll now continue with the second part of worksheet 10J, graphs of sine function. I'll be going through a few examples on how you can sketch the sine function, and then I'll leave you all to try the rest on your own. Okay? Alright, so first let's go into example 1. The function is defined by fx equals to 3 sine 2x minus 2. Okay, so the first few parts of the question, part 1, part 2, part 3, is actually there to guide you in terms of how to sketch the graph. Right? So just a quick recap. When they give you the function, you can identify three things: A, B, and C. Right? So in this question, the A represents 3, the B is 2, and the C is negative 2, right? And in my previous video, or rather in the previous page, we shared that A affects amplitude, B affects the period as well as the number of cycles, and C affects the position of the graph, right? And that means it affects the maximum and the minimum point, how the graph move up and down, etc. Okay, so I'll show you over here. So if A is 3, then the amplitude must be 3. Okay, and then the period, if you remember the formula, period is given by 360 divided by B, right? And in this case, B is 2, so that means that period is 180 degrees. Okay, which means that one cycle is 180 degrees. That's what it means by period. Alright, and then next we look at the maximum and the minimum values of the graph, right? So remember we spoke about how the graph or the C value affects the middle line, the so-called the middle line, right? So the middle line, if C is 0, then the graph is just like this, right? Like that. But the moment C becomes negative 2, the entire graph will have to be shifted down 2 units, right? So it will go something like that. Okay, so which means that the crucial points, the maximum and the minimum point, will all be shifted accordingly, right? And in this graph, what's our maximum point? According to our amplitude, that is 3, right? Our amplitude is 3. So that means that if it's at C equals to 0, our maximum is at 3, our minimum is at negative 3. But the moment C becomes negative 2, we will have to move down the maximum by 2 units. 3 minus 2 gives me 1, and then negative 3 minus 2, this point here will be negative 5. Okay, so now, so this is the part where we will be able to get our maximum and minimum value. So our max will be 1, our minimum will be negative 5. Okay, so this is based on the amplitude, right? So amplitude gives us the maximum and minimum. By default, it will be from negative 3 to 3 because the amplitude is 3. But because of the C being negative 2, that entire maximum and minimum will shift down by 2 units. Okay, so that's why it became 1 and negative 5. Alright, so now we are done with all the part 1 to part 3. We can now sketch the graph. Okay, here take note that because if you look at the decimal software, right, the graph actually extends to infinity on both ends, right? So in the exams, you will always be given this range of x values or range of values that you are supposed to sketch your graph for, right? So this will ensure that you don't have to submit infinite number of graphs. We just need a certain segment of the graph. Okay, in this case, they want from 0 to 360. right? And earlier we found the period is 180, right? So if one cycle is 180, then from 0 to 360, you will have to draw 2 cycles, isn't it? Okay, so this would mean that you have to draw 2 cycles. Okay, so we're gonna divide this into 2 parts. One, let me use black or blue. 1, 2. Okay, you want to use a pencil to sketch your graph as much as possible. Alright? Okay, so this will be 180. This will be 360. Okay, so I'll be drawing 2 graphs over here. Now, if you look at the sine graph, right, there's the mountain, and then there's the trough, right? So for each graph, or rather for each cycle, I will have to further divide into 2 parts so that I can get my mountain out, right? So this is 90, this is 270. Okay, so but I also need to mark out the maximum point and the minimum point, right? So so I will need to have further cut it here as 45. This is 135. This is 225. And this will be 315. Okay, so as much as possible, you should try to draw it to scale. Okay, you can use your ruler to help you with that. Alright, okay, next we will mark out our middle line or our axis of the curve. In this case, it's at -2. So this part you can use okay, maybe I should demonstrate using a ruler. So just draw dotted lines so that later on we can use the relevant parts to we'll be able to draw clearly. And then we have maximum at 1, so somewhere here. Sorry, draw dotted line, and this is at 1, and then the minimum is at -5, so somewhere here. Okay, so while you don't have to be like super accurate, you should try your best. Okay, because it's a sketch, you don't need to be super accurate, but your diagram should be as much as possible drawn to scale. Alright, if not, it will affect how the graph looks like, because the graph is supposed to be symmetrical. Okay, alright, so now we know that the graph goes up and then comes down. So it starts at -2, and then it will go all the way up to the maximum value at 45 degrees. Right, this is the max. Then it will come down to -2 again at 90. Right, this is the pattern. Okay, and then after you go down all the way to -5 at 135, and then at 180, then -2 again, followed by the maximum at 225, again at -2, and then followed by the minimum again at 315, and lastly at -360. So now we can draw our graph. Okay, it's a bit ugly. Let's try again. Right, mountain, trough, mountain, trough, and okay, must pass through the point, and mountain. Okay, that's the end. Okay, so okay, I don't like this part. I'm gonna redraw. So as much as possible, your graph should look symmetrical. Okay, and 2 cycles and all the key points. So these are all the key points that we mark: the start, the maximum points. All these are the crucial points, okay, that we need to see, essential points that we must see in all your graphs. Okay, so this would be example 1. Alright, so now you can go and try example 2 on your own. Example 2 is very similar to example 1, slightly easier. Okay, and we're going to jump to example 3. Okay, and example 3, it's slightly different. Okay, so now let's go to example 3. Okay, so the graph is defined by y equals to 2 sine x over 3 plus 1. Okay, so same thing, identify your a, b's and c's first. A is 2. Okay, look at the b. B is the coefficient of x, right? So this actually can be written as 1/3 x. So therefore, b is actually 1/3. And then here is our c. Our c is 1. Okay, so because a is 2, amplitude will be 2. The amplitude will be 2. Our period is given by 360 degrees divided by 1/3. Right? The formula is that. Okay, maybe I should write like that. Divide by 1/3. So it's 360 degrees times 3 over 1. Keep change rate. And that gives us 1080 degrees. Okay, which means that one period of this graph is a huge, it's like super stretch, 1080, right? So, okay, that's interesting. And then when c equals to 1, it means that the entire graph here is actually shifted up by 1 unit, like that. Okay, so this line here, the middle line is at 1. Okay, this is called the axis of the curve. Alright, so now we can start. Okay, now we can start. If the amplitude is 2, it means that the height here is 2. And then if the axis of the curve is at 1, that means the maximum value will be at 3. And the minimum value is at 1 minus 2, that will be negative 1. Okay, so now we can draw. Oh, but before that, we need to figure out how many cycles we need. So here, we are asked to draw from 0 to 540. But our period is 1080. So what does this mean? Do we have to draw one complete cycle? No, right? Because we are only asked to draw until 540, 0 to 540 only. That means I'll cut off here. This part is 540, right? 1080 divided by 2 is 540. So, essentially, you're only supposed to draw half a cycle. Well, that's easy. So I just have to draw the mountain. Okay, so this is 540, right? But it's still important for us to mark out the important points. The mountain peaks right in the middle of 540, which is 270. Right? Then, at the same time, the graph starts at 1. So our graph, okay, sorry, I need to pull out my ruler again. Okay, at 1. And then the maximum value is at 3. And then the minimum is at negative 1. Okay, but although in this case we don't actually meet the minimum value, I'm just going to leave it there. So this is negative 1. 1 and this is 3. Okay, so I know that the maximum value of this graph is at 270. It starts at 1, it goes up, and okay, don't exceed. Draw again. Then it comes down. Oh yeah. It's a bit difficult to draw on the iPad. At 540. Okay, so these are the few critical points as per usual. Here, here, and here. And that's it. This is our example 3. Okay. Last example, I will provide you some guidance for example 4. And then you can try on your own. Okay. Right, for example 4, our graph is our equation looks a bit odd this time round. It's not the same as, our what we were told, the general sine function. Looks a little bit different, but I can just reorder it so it looks familiar, right? Just have to swap the constant with the sine function. So from here, our a is actually -3. Our b is 2, and our c is 1. Now, what happens when a becomes negative? In my previous video, you have saw me explore the Desmos function. When I pull a to become negative, the entire graph actually flips, right? So what I'm trying to say is, if a is positive, the graph looks like this, with the maximum being at -3 and the minimum being at -3. However, the moment I put a negative sign in front, this part, the entire graph will just flip. Like, okay, not drawn very well. It will just flip upon the on the axis of the curve. Okay, so this is the part where, but it's a bit complicated, but you notice that the entire graph's period and amplitude doesn't change. The graph just flipped because you multiply a negative sign to all the points. So whatever is positive now becomes negative. Whatever is negative will now become positive. So the whole thing will just flip. Okay? So the way we do the things are the same. Just that now we have to remember that the graph goes down before it goes up. Previously, it forms a mountain first. Now I form the trough first, right? Okay, so amplitude of the graph still 3. Period, same formula, 360 divided by b. In this case, b is 2. So, oh, sorry, not 360, take note, radian mode. So this must be changed to 2 pi. Okay, which means that the period is pi. Alright, great. If you see that the period is pi and the cycle is from 0 to pi, it means that you just have to draw one cycle. Okay, so now we can start. Our axis of the line is at y equals to 1. Then because my amplitude is 3, so I'll plus 3 to go up. Plus 3 to find my maximum. 1, 2, 3. So 1 plus 3 is 4. And then I will minus 3 to find my minimum. Right? So that is somewhere here. So this will be -2. Okay, so now I'm done with this. And then I will want to mark out my x-axis now. 0 to pi, so we just have to draw until pi. The middle, somewhere here, is our pi over 2. Okay, but remember there's the mountain and the trough, right? So this part is pi over 4, and this part will be 3 pi over, 3 pi over 4. And then, remember we have to go down first before we go up. Okay, so this part will be this is our starting point, followed by here, followed by here, followed by up, 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 and followed by here. So the graph looks like this. And this is the answer. Okay, that's it. So remember to try example 2, then we can go through if you have any questions in class. Okay, you can also try the rest of the questions in SLS to test your understanding. Alright, see you tomorrow.